Hello everyone, welcome to the Engineering Bard Show. I am your host Andrew Dunlop. We got a great show. What you see is what we're going to be doing. We're going to be counting those boxes. So let's go ahead. All right, so the E-Manager says, let's design a box counter prototype. I'm very proud of this project. It's a cross between basic and intermediate, although there is some challenges there. So let's design a box counter that when a box crosses the sensor threshold, the BCD will the binary coded the decimal. That's what that means. Will in hexadecimal form. I have to go over that again. Will go up to FF and they'll then go back to 0. And then we want to count on the console. You know, the console on the computer there. So this is an ideal box counter. So when the box crosses the threshold, a sensor, a second will go, and then another box will come, and it will count. Kind of like what you see in Amazon or UPS or I don't know. And we want to use modular programming on some functions. This may I'm gonna use that. So just keep your thinking cap on when you see this stuff because it can get kind of confusing. Okay. Here's the part of the project that I described on the PowerPoint, but I want to get more of a visual. That right there is a double BCD driver. You're going to use 2 of them. Okay. So each one is going to count from 0 to 9 and then A through F. So it's going to be counting in hexadecimal. Also, what I want to do is, see, there we go. And so I'm going to introduce a few things to you. And it'd be nice. And then, so there's going to be a sensor in between the boxes. Okay, so can you guys see that? So let me see. Can you guys see there's another box, okay, on the table? Okay, so since we don't have a conveyor belt, this is just a prototype. And all my stuff is prototypes. Okay, so as the box comes down, there's going to be a sensor. You can use any sensor you want, and it's going to count 1. And then you can put the box 2, 3, so on and so on till FF. Also, not only is it counting here, I also want it to count on the console of your computer. Okay, so it's going to be counting on the console and counting on the BCD at the same time. You can use whatever microcontroller you want. This is the Raspberry Pi 5 right here. There is a lot of uses for this. I don't recommend using this for the BCD driver, but I do recommend there's other uses for it that's beyond the scope, okay? It's beyond the scope. This is what I'm going to use, the ST Nuclear F411RE, F411RE, okay? So if you guys can see that, okay? And what we're going to do, and this is the Arduino. You can use the Arduino IDE. I don't mind. This is the Freescale, so I'm not really advertising anything, okay? This is Freescale right here. This is a great one too. I just prefer this one. This seems to work. This seems to like me a bit better than that one. Then what we want to do is we want to embed it. So let's put everything in here so you don't see it. And then we're going to put this, and then everything's going to go in here. Or, I mean, everything, all you see is just this. Okay, that's the ideal thing. And I got these wonderful boxes right here because I'm slightly behind because my computer last week it malfunctioned on me, and I had to replace the power supply, the motherboard, and the graphics card. It was horrible. So that should give you the gist of it. And let's go off to the next section. Okay, so here we're going to stop the video, design, build, and code the project. This is for advanced users, so if you don't know anything, don't stop the video. These are for people that want to challenge themselves. There's a few people in my audience that you know, in a way, makes you a better engineer. If you just kind of like a math book, you look at the problem, you do the problem, you check the back of the book. Basically, anything past this is the back of the book. All right. So let's go off to the next section. I think that's the parts list. This is the parts list for the project. So we want one breadboard or PCB if you're quite fancy about it. 14 330 ohm resistors. These are resistors right here. Okay. A laser pointing cat toy. That's that thing right there. This is called a Vishay BPW77NA photoresistor transistor. It's not a really great picture, but it's a device. It's a sensor, basically. An embedded device. I say it could be any device. A laptop computer that downloads an IDE in C++. I prefer Embed Studio because now we're talking the same. At least C++ is just a kernel program, but this program has its own functions and own methods to call the. So I like to use the Studio. It just, to me, I'm very familiar with it. A one dual BCD common cathode DC5611EHA. That's this thing right here. If you get a common anode, just remember when we go over the pre-code area, and I remember it's the opposite. So instead of a 1, it's a 0. It's the only difference. And then instead of going to ground, it's the 5 volts. And then the ground is the actual the device. Assortment of wires, a female familiar. It's good to have a little cat right there, and one patient human being. I say that this project is more tedious than actually difficult. Although the code, there is a little bit, you got to be kind of clever with the code. But I don't find the code all that challenging. I find what was challenging was getting the wires in the right spot, and also sometimes you'll find out that some of these resistors are pretty thin and they don't connect well. So if you got a PCB or something like that and you want to solder it on there, then I believe you'll have a better. But if you do on PCB, just understand that it's very thin, and you may see a segment go out and just kind of wiggle the resistor right there, and it will basically appear. Okay, so let's go to the next section. We're going to talk about some of the parts, and then after that, we're going to talk about the AutoCAD section. Okay, this is the data sheet on the silicon NPN transistor right here. You should always look at these stuff, kind of just to see what it does. On the next video, I'll show you what it does on the scope, just very pragmatically. So the nanometer is 480, 80, up to 80 volts. I mean, it could handle a lot. 70 volts. So this is just peak current, 50 milliamps. I put in a 10K in there. Just it seems to work pretty well. And so this is how power dissipation. So you just kind of look at. You see, it's a very linear device. This is a very, very linear device. I'm trying to find the. There, I think. There's the wavelength. So it certainly is the most sensitive at 800 nanometers. I think that's red. I'm pretty sure it's the most sensitive there. That's what it responds to. The wavelength right here is the type of light. So anyways, and these are the the dimension. Okay, I'm going to show you guys something. This is part of the project there, but we're going to use a photo transistor, okay? So if I shine this laser beam onto the photo transistor, you should see that the transistor, you see how it goes all the way up? If I do it just perfectly, I'm doing it by hand, it'll go to 3.3 volts. Once I take that away, it goes to 0. So when we use this device, it has to be lined up very precise. I shake back and forth, but once it's on the table and it's set perfectly, it will basically be act kind of like a switch. So when the switch goes low, it's going to count. Okay? So that will give you an idea of how that works. It's called a photo transistor. You can get on Amazon. I don't know, it's like $1, it's a couple bucks. I have no idea. So yeah, let's go on to the next section. Okay, so this is the I'm using a different microphone. This is the DC5611EWA. This is this is by DigiKey. So shout out to them. I watch them on YouTube too. Those guys are great. This is the dual BCD driver out there, and this is their pinout, and this is King's Bright. Now I don't want to. I'm going to criticize them a bit. This is very confusing. This 1, 14, 13. So I had to on the next section is the AutoCAD section, and this shows you where the pinout is, kind of, but it's not as clear. Okay, but anyways, it uses gallium arsenic phosphate. That's just the red. That's the material that he uses. So this is a common cathode. Yeah, that's right, common cathode. And this another. It's always good to kind of look at the data sheet again, especially when it comes to the pinout. But I have that. So let me go back here. Let me see if I can kind of. Is it? See, there you go. There you go. Nice and big, right? Nice and big. See that? That's the pinout. And so this is always sort of take a look at it. Reverse voltage, operating temperature, 85 degrees Celsius. So it can handle a lot of heat. So remember, 100 Celsius is boiling temperature. So this is pretty hardy. Okay, so you just look at it. I'm going to go pretty quick, and there's the red. 650 nanometers is the red. Oh, so it must have been purple. Okay. Actually, it goes red. Actually, the red's the top, and then it's infrared. It's infrared. That's right. Okay, that's right. A little bit of flashback. Okay, this is the packaging. Okay, so that is the data sheet. Now next is going to be the AutoCAD section. So I'll see you there. So this is the AutoCAD section here. This is a very involved project, and I wanted you to check out how I did my schematic. And so my schematic is really more straightforward. So let's go ahead and zoom in. This is how it's going to be on that device. So you got your two grounds here. This ground controls the right side. Okay, the right side is the least significant digit. The left side is the most significant digit. And you wire it by following the alphabet. A, B, C, D, E, F and then G. We don't use a decimal point in this one. So that's always going to be off. There's some that will. So the second side, but observe the differences. The left side is not the same as the right side. You see there's an A, B, that's true. But the C's down below, but the G is switched. The G's up here. So be careful of that. Now, let's go off to the project itself, which is the box counter. The box counter, now you could do it many ways, but I just decided to make this a little bit more simple by wiring up all the ports. So you wire up all the ports. So if you look close now, if you're new to my channel, which most of you guys are, the dots mean it's connected. Where the lines cross over, that means it's not connected. That means it's avoiding it. It's really difficult to wire the schematic up without crossing the lines. So where there's a red ball, that's called like a node, okay? And where it connects the node, it is connected to the port. Okay, so let's go ahead and take a look at it. So the A is connected to a 330 ohm resistor, and if you follow it down, is connected to PC0. So PC0 is the first that's in the bus out. All right, so PC0, PC1, 2, 3, 4, 5, and 6. Okay, it has to be set up in that order. At least has to be set up in that order in the bus out array. The PC7 is the next one. PC7 is A, and it is indeed connected. And it goes PC7, 8, 9, 10, 11, 12, 13. And the sensor, which is kind of interesting, is I have it connected to the 3.3 volts on the device. You can do that, and it's okay. And the sensor is more of a diode. So this is the symbol for a light emitting diode, or not? No, yeah, a photodiode. Excuse me. And it's connected to the 10K, but I have a digital in, and it senses very well when the switch is on this side. Okay, so don't feed it in the switch directly. You sort of feed it in the digital in indirectly, and so that is a good way to go. I think I showed on how the photo transistor worked. So it's going to work as the box crosses the laser beam. It's going to count. Okay, so let me go ahead and zoom out, and I'm going to try to get you guys the best picture possible. Okay, so you might have to take several pictures. So this one right here. Oh, and that is connected. That right there is my funny drawing of the ground. So everything I did is this is all handmade. Okay, so there's that one right there. Sort of take a picture of it, or just probably be easier if I zoom out. There you go. Go ahead and zoom out. Okay. And the words, everything is a 330 ohm, except for the photo transistor, which is connected to a 10K. All right. So let's go off to the next section, which is the code talk. So we're going to talk about this right here, A. So anywhere you see A is a 1. And we're going to go this way. Okay, not that way, this way. So A is filled up, it's red, it's a 1. B is filled up, it's a 1. C is filled up, it's a 1. D is empty, so it's a 0. E is filled up, it's a 1. F is filled up, it's a 1. G is filled up, it's a 1. It's a 0. Okay, so it's going to be 0, and then the cool thing is we separate it. So we do this first, then that. So it's going to be 0x. Hold on. Let me see if I can. So A equals 0x, and okay, there's a 7. That's it. That's A. That's going to make that shape. Okay. Okay. So now we're going to do B, and this is once again, where it's blank, it gets a 0. Where it's red shaded in, kind of, it gets a 1. Okay. So let's go ahead and go through our chart right here, and we're going to do B. Let's erase this real quick. That was A. And B, of course, is lowercase, because if you do uppercase, it looks like an 8. Go. All right. So A is 0. B is 0. C is filled. 1. D is filled. 1. Okay. And then E is filled. Okay. F is filled. All right. G is filled. Okay. Decimal point always 0. So we look at our chart right here. That's going to be 0x. That's a C. Okay. Yeah, that's a C. And this right here is going to be a 7. B is 076. All right. So the next one is C, and C has this shape. So we follow the shape again. So A, it looks like it's filled. B looks like it's not filled. C, it's not filled. D is filled. E is filled. F is filled. G is not filled. So that's going to be okay, so it's going to be, so C is 0x 9, and that's 3. That's right, 3. Okay. 0x9. That's it. That's 39. So we're going to do D. So as you know, what fills in? So A is blank. That's 0. B is 1. C is 1. D is 1. See, it's red. E is 1. F is 0. G is 1 and 0. So D equals 0x. I think that's E's over here, and that is a 5. 0x5E. This one's the E. The E is pretty simple, because I think they're all pretty simple. So once again, red 1, B 0, C 0. You don't see nothing there. D 1. E, there's something there. 1. G, F is 1. G is 1. Decimal point is always going to be empty, so it's going to be 0. Okay, hold on. Wait. So now let's go ahead and do it. That's definitely a 9 right there, and that is a 5, 6. That's a 7. 0x7. Last one, of course, is F. This is after that. That's it. So let's go ahead and do that. So it looks like we got the A is filled. 1. B is empty. C is empty. D is empty. Okay. E is filled. That's 1. F is filled. That's 1. G is filled. That's 1. So that looks like it's going to be, so F equals 0x, I think that's a 7, I'm pretty sure. 7, 1.
Okay, this is the code talk section. So everyone, we finally made it. Okay, so before I begin, there's going to be, I bet you're going to have some questions, because you're going to be looking at, I did this code a little bit differently. And let's go ahead and start, and I'm going to try to go slow. So I got the include, and I made up my own hashtag include mod codes, header. Okay. So the clear screen, the home screen, and the go to screen is here, but let me think. Where is. Here are the mod codes. Okay, there you go. So to do this correctly, let's do a kind of a small review. Is we want to include the mod codes header, and then we copy and paste the clear screen. The all this stuff right here. Let me see if you guys can see that. There you go, nice and big. Okay, so there is the codes. Okay, it's on a .cpp. I should, that is right click .cpp. Then, so take a picture of that real quick, okay? But then this depends on the header, okay? So the header has this in-depth, I call it mod codes, define mod codes. And you put the function part where you call the function inside the header part. It's between the define and the endif. However, you always got to include the embed.h. Okay, that always gets included. So that gets included. All right, let's go towards the main. So there it is. It's functioning towards the main. We understand. So people who are new here, what those mod codes do is when I compile it, we're not going to compile it here. We're going to compile it on the it's already been compiled on the proof section. You will see that you'll have a title screen, which is going to say light sense. I call it the welcome wagon, but it's nice, but it is technically it's called a title screen. And then underneath there, it's going to count. Okay. So, and so what that does, it stabilizes the data onto one spot instead of goes all the way down the floor and just it's all over the place. You're like, it's very difficult to manage. Okay, so there I made a Boolean on state int voltage. Okay, so that I put into the segments. Okay, so let's go over there real quick. Inside the segments, I declared the variable here. Okay, it's include it double segment header. Okay, so I put most of the variable ports inside the .cpp file. So there's the bus out, the LCD digits. This is in its own file. Okay. And then there's also a Boolean on state. Okay. So when the voltage goes to 1, I showed you when it hits the high mark, it's basically going to count a box and it returns true. Okay. So when it returns true, and then there's the LEDs. Go ahead and check these things out. Okay, so I'm going to go slow right here. From here to here, this is the hexadecimal from 0 to 9, and then A to F. And it's all on one array. Okay, LED array. Let's go to the header file. This is the double header file, the double segment header file. So on the double header file, it's the same thing. If and def double segment. You just have to put something here. They prefer the capital. I know the ones wasn't capital, but it's supposed to be capital. Defines double segment, and then you include that. Now you put on the variables that come off of your development board. You put the word extern. Extern means it's external from the main. It's outside of the main. That's what that means. And it's a bus out. So this basically says, okay, everything here has been declared. I'm ready to go. So extern in LEDs, Boolean on state, and if. So take a picture of that. Now let's go towards the main. Okay, so and then what you got to do is include it. I know this is going to be difficult, but we're going to be doing this a lot. So if you have any questions at the very end of it, all I ask is for an email if you have any questions. Now, this is sensor.read voltage. The voltage was declared here in the main. And then if the sensor reads, if it comes to a high voltage, this is going to become true. So if it's true, this is a Boolean statement, then it's going to count 1. And then it's going to wait a second. And then I didn't put a wait down here because even though it's going to flip back and forth really fast, if I put a wait down on this section right here where the go-to screen is, it's going to conflict a bit. It's going to conflict a lot. It may miss this right here because remember when you put too many wait functions into your code, and there is ways around that, and we're hopefully one of these days, it's something called timers and tickers. Timers or tickers are a very clever way of timing it without freezing the microprocessor. So it's going to count. The thing will count forever. If you don't put this right here, if the count is greater than 255, so 255 is when there's 2 FFs, each F is 4 bits. So there's a 4-bit there and a 4-bit there. And so when all the ones are filled, it's 255. When it goes above 255, it's going to reset everything down to count 0. So the count is the count is in these arrays. These arrays, the less significant digit and the most significant digit. Okay. The less significant digit is in a mod. So when it's 1 divided by 16, 1 mod 16 is 1. 2 mod 16 is 2. 3 mod and 0 divided by 16 is 0. So it's going to go, so it's just going to read that. So it's going to be 0. Okay. These right here is, as you know, was declared in the header file. No, the CPP. These codes, as I showed you, are the hexadecimal codes. When it goes 0, it's at 3F. When it goes to 1, 0, 6, 2, 05B, 3, so on and so on and so on. The least significant digit is 0 through 6. That's the one on the right side. Okay? That's the one on the right. So that's the least significant digit on the I'm trying to get my words right. On the binary coded decimal driver. Okay? And on the left side is the most significant digit. That's the one on the left side, just like 10. Just like on the left side. The left side of the number is the most significant digit. It is also attached to different ports, the bus out ports. Okay? The digital in is the sensor. The sensor is the diode, the light sensing diode. Okay. Are you guys following me so far? Okay. I'm speaking a different language. I get it. I get it. Okay. So as it counts, it's going to go up to 255. And right here, it's going to print F to the screen. Okay. So hope you guys understand that. Hope you guys know how to do the modular programming, because that's what it's going to be from here on out. And if you have any problems, like I said, email me. I get it. Because this is going to get into, this is not easy stuff. So let's go on to the next section.
So behold, this is the box counter. 1. See my hand? It's going across in the laser beam. 2. I always think this is an E. 3, 4. I usually keep a second. 5, and so on. Thank you. Please subscribe, if you don't, or at least make a comment. And I'll see you on the next Engineering Bard Show.